When the Royal Air Force christened its next fighter Tempest, it reached back to the Hawker Tempest of 1944, a piston-engine thoroughbred that helped turn the tide against the Luftwaffe and signaled that the United Kingdom intends to influence the future of aerial warfare as decisively as it shaped the past. The modern Tempest, now the centerpiece of the trilateral global combat air program with Italy and Japan, is conceived not as an incremental successor to the Eurofighter Typhoon, but as a technological moodbreaker stealthier, more powerful, and far more digitally integrated than anything currently airborne. Brexit, strategy reviews and the genesis of Team Tempest. Although London had discussed a Typhoon replacement for years, momentum truly built after the 2015 Strategic Defence and Security Review. Brexit then added urgency. Outside the European Union, the UK needed a large, visible, high-technology project to anchor jobs, nurture sovereign design skills, and preserve an industrial ecosystem that might otherwise migrate to continental programs. Whitehall therefore unveiled the Future Combat Air System Technology Initiative, which morphed into Team Tempest in 2018 when a full-scale model was pulled from under a tarpaulin at the Farnborough Air Show. From day one, BAE Systems led overall air vehicle design, Rolls-Royce shouldered propulsion, Leonardo UK took sensors and avionics, and MBDA steered armaments. The British Treasury set aside roughly £2 billion, about $2.6 billion, to carry the project through its first 7 years, an unusually hefty line item for a concept still years from flight. Joining forces with Rome, Tokyo, and Stockholm, a sixth-generation jet is ruinously expensive for any nation to build alone, so London courted allies whose strengths complemented its own. Italy's Leonardo brings radar processing prowess and advanced composites. Sweden's Saab, an early participant in technology workshares, contributed digital design tools. And Japan, keen to replace its F-2s with a homegrown FX, added deep expertise in miniaturized electronics. In December 2020, the UK, Italy, and Sweden formalized cooperation. Within 2 years, Japan merged its FX with Tempest under the Global Combat Air Program banner, forming a business venture that splits equity equally between BAE Systems, Leonardo, and Japan Aircraft Industrial Enhancement Corporation. A delta wing shaped by stealth and speed. Tempest's exterior looks conservative at first glance, twin-engine, blended body delta with canted tails, but every line is drafted around the physics of low observability. Its curved inlets bury the fan faces from hostile radar, inch-perfect seams avoid disrupting laminar flow, and the bulk of the weapons migrate to capacious internal bays so pylons do not betray the aircraft to enemy search radar. Engineers settled on an overall weight band that falls between the Typhoon and the F-22, trusting that new materials and very high thrust-to-weight ratios will keep the jet agile despite the mass added by buried stores and fuel. Rolls-Royce's 1 megawatt promise. The beating heart of the program is Rolls-Royce's next-generation power plant, a twin-spool low-bypass turbofan designed to exceed the Typhoon engine's electrical output tenfold. By embedding starter generators directly on the engine core, the company eliminates heavy accessory gearboxes and frees enough shaft power to produce around 1 megawatt of electricity in flight, enough to feed gallium nitride radar arrays, high-energy lasers or microwave weapons, while also chilling infrared hotspots that would otherwise expose the jet to heat seekers. The development roadmap, which began in 2014 under the Embedded Electrical Starter Generator banner, is now in its third phase, marrying dual electrical loops with advanced heat exchangers that can shuffle thermal loads around the airframe like a circulatory system. Sensor fusion and the AI co-pilot. Leonardo is building an all-digital nervous system that treats radar, passive radio frequency antennas, infrared cameras, and electronic warfare receivers as facets of a single wideband aperture. Where legacy radars pivot a dish, Tempest's arrays steer pencil-thin beams in microseconds, scanning, jamming, and data linking simultaneously. That torrent of information will overflow any human pilot, so the jet carries an onboard, virtual co-pilot. An AI able to fuse sensor feeds, plot firing solutions, and even fly the aircraft home if G-forces knock its human unconscious. Helmet-mounted displays overlay augmented reality symbology directly on the pilot's eyeline, transforming the cockpit canopy into a three-dimensional tactical globe. 30% 3D printed, all modular. Where the Hawker Tempest was riveted aluminium, the Global Combat Air Program Tempest is as much software project as aeroplane. BAE plans to grow roughly a third of the structural parts in additive manufacturing machines, using laser-fused metal powder to build honeycomb lattices that balance stiffness, weight, and radar transparency better than old-school milled titanium. Internal architecture is deliberately plug-and-play. Weapon bays sized for future missiles, photo reconnaissance pallets or extra fuel. Sensor apertures that slide out like drawers for rapid midlife upgrades. And open-source mission system code that any partner nation can tweak without unpicking the entire operating system. Missiles for every occasion, and drones for the rest. Tempest's principal armament will ride inside 2 main bays thought to accept 6 to 8 long-range weapons. First in line is the joint new air-to-air missile, which welds the Japanese AAM-4B's Agile Active Seeker to the UK ramjet-powered MBDA Meteor body, promising Mach 4 speed and endgame maneuverability far beyond current joint new air-to-air missile stocks. Land Attack Punch may transition to a follow-on to Storm Shadow, optimized for internal carriage and low-level terrain masking. Yet the most radical concept appears outside the fuselage. Loyal wingman drones, disposable or semi-expendable, that scout through surface-to-air envelopes, carry extra missiles, or simply show up on hostile sensors as ghost images to draw fire. Britain's lightweight, affordable novel combat aircraft project is already flight testing candidate airframes for this role. From Farnborough, mock-up to flight-ready prototype. Digital engineering permits parts to be printed, assembled and stress-tested in silico long before metal arrives on factory floors. Even so, Tempest must prove itself in the air. BAE's Wharton plant in Preston is machining titanium bulkheads and composite wing skins for the first flight test aircraft, scheduled to fly in 2027. That demonstrator will not be full mission capable. Its job is to validate inlet performance, thermal management and stealth coatings, and to shake down Rolls-Royce's power and propulsion suite. Because the Global Combat Air Program partners are committed to fielding an operational squadron by 2035, any problem discovered on the prototype will have to be fixed inside an unusually compressed development window, roughly half the gestation time of the F-35 program. Economics, diplomacy, and the lure of Saudi capital. Even with international help, the price tag is eye-watering. The UK has penciled in more than £6.5 billion, $8.3 billion, for its share of research and development alone. Global Combat Air Program's corporate leaders therefore court additional investors, Saudi Arabia chief among them, offering assembly work shares and technology transfer. Riyadh's inclusion would pour oil money into the program, but would also offend Italy's sensitivities over Yemen and could complicate Japanese arms export restrictions. The decision remains politically fragile. Yet the venture's backers argue that the fighter's economic value extends beyond aerospace jobs. Tempest is a diplomatic calling card, a technology incubator and a sovereign insurance policy in a world where F-35 software keys are held in Fort Worth, not Farnborough. Air superiority as a system of systems. Why gamble billions when drones stalk battlefields from Ukraine to Gaza and hypersonic missiles threaten every concrete runway? Because air superiority remains foundational. Armies that lack it huddle under camouflage and hope. Tempest, however, is not just a manned fighter, it is the hub of a wider system of systems. Secure cloud-native networks will let it queue satellites, surface radars, cyber nodes, and unmanned adjuncts in real time. The aircraft's onboard processors are expected to act as flying data centers, crunching terabytes at the tactical edge and distributing intelligence across the battlespace faster than enemy anti-access bubbles can adapt. What could still go wrong? A schedule that promises a first flight in 2027 and frontline service 8 years later leaves scant slack for software debugging or industrial delays. Japan's Ministry of Defense must reconcile its conservative acquisition processes with the UK's faster-fail philosophy. Italy faces budgetary squeeze. Sweden has stepped back from full partner status to observer, and Washington's next-generation air dominance fighter looms as a rich adversary in export markets. Add to this the risk that advances in counter-stealth radar or space-based surveillance could erode Tempest's edge before it reaches mass production. If you enjoyed this deep dive into the future of air combat and the incredible tech behind the Tempest fighter, don't forget to hit that like button. Want to stay ahead of the curve on cutting-edge military tech? Make sure to subscribe and turn on the notification bell so you never miss an upload. For watching and being part of our community. See you in the next video.